Okay. Now we have this problem. This is problem number 2. Okay. So pretty much similar to the last problem, right? So we're comparing numbers. We're comparing decimals and fractions. Okay. So we have a number line 0 to 10. I mean 0 to 1, 1 to 2, and there are 10 bars in between, right? 10 little lines in between. So how do we approach a problem like that? What does the bars represent? Well, those are decimals or fractions from 0. Notice that you have 10 bars, right? You have 0, then you have 1, right? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So you have 9 um, and then 10, right? So each one of the bars represent 1/10, right? They represent 1/10. Let me write it down. So each one of the bars represent 1/10. All right, 1/10. Okay, so this is 0/10, 1/10, 2/10, 3/10, 4/10, 5/10, which is half, because 5 is half of 10, so that's half. Then 6/10, 7/10, 8/10, 9/10, 10/10, which is equal to 1, right? 10 divided by 10 is 1. And then if you were to continue, this is 1, and then that bar right here would be 1/110th. 1/2, 1/3, 1/4, 1/5, 6/10, and so on and so forth, right? So that's how the number line is measured. Okay. So if we don't want to say 1/10, we can say something else, right? We can say 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Once you get to 0.9, that's 1, right? That's 1. So that's how you got to look at a number line like that. You count the bars, there are 10, so each one of them is 1/10, right? Is 1/10. And if you look at them as decimals, they are 0.1. Okay. So when we look at x, let's see where exactly x locates itself. So this is 1/10, 2/10, 3/10. 4/10. This is 5/10, which is half, right? 5/10, which is the same as half. And remember, if we count it as 0.1, so that would be 0.5. 0.5. Okay, perfect. I hope you guys understand that, right? Because this is 0, this is 1/10, 2/10, 3/10, 4/10, 5/10. But notice that is halfway in the middle, right? It is the same thing as 1/2, because when you simplify 5/10 by 5, right? 5 divided by 5 is 1. 10 divided by 5 is 2, right? So that's why we call it half. Okay. We can also call it 0.5. How do we know? Because this was 0. This is 0.1, 0.2, 0.3, 0.4, 0.5. All right. Makes sense. Okay. So now let's continue. Notice that this is in between, right? So this is in between. So this is 1 and 1/10, 1 and 2/10, 1 and 3/10, 1 and 4/10, 1 and 5/10, 1 and 6/10, right? 6/10, and then 1 and 7/10. So between 6 and 7, you have half, right? Between 6 and 7, this is in the middle, you have half. So this is 1 and 1 and so that was 1 and 6/10. So this would be in decimal form 1.65, right? So 0.1, 1 point, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, right? And then this is 1.7. So this is in between 1.6 and 1.7. So that's 1.65, right? This one, y is 1.65. So 1.65 because it's in between. And then if we continue on, this is 3, right? And that's 3.1. 3.1. Now, let me remove this out of your mind when it comes to the inequality signs, the greater than, the less than, right? Greater than, less than, greater than or equal to, less than or equal to. The alligator mouth will always eat the largest number. Let me say it again. The alligator mouth will always eat, yum, 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 the largest number. So if I'm comparing 1.65 and 3.1, listen, it doesn't matter where I put the 1.65, right? And the 3.1. I'm sorry, this is 3.1. 3.1, or I'll turn it around, 3.1 or 1.65. The alligator mouth, right, will eat the largest number, right? So consider the sign, the inequality signs as a mouth, right? The alligator mouth will eat the largest number. So in the first one, let me use a different color, red. The alligator mouth, watch this, right? Eats the largest number, which is 3.1. I can make it look like a mouth for you so you understand, right? Yum, yum, yum. So the alligator mouth eats the largest number. The second example, I just see the alligator mouth again will eat the largest number. So I don't need to know, does it look backward? Does it look forward? Which way does it look? No, my alligator mouth will eat the largest number, period, right? So if I want to compare all of these numbers, right? So the alligator mouth going to continue to eat the largest number. So I have 0.5, I have 1.65, and 3.1. So if I'm gonna put them in order, right? The first one I'm gonna start with is the 0.5, which is half, right? 0.5, which is half. So I'm gonna write 1/2. Okay, so I write 1/2. Okay, alligator mouth gonna eat the next largest number. What is it? 1.65. Okay, that's gonna have to be the next one. 1.65. And then the next alligator mouth gonna eat the other largest number, which is the 3.1, right? Or 3 and 1/10, right? 3.1 is the same as 3 and 1/10. I want you to understand that because if we keep the fraction in mind, the 1/10, the z is 3 and 1/10 or 3.1, right? So 3.1 or 3 and 1/10. So 3.1 or 3/1/10. Now, when we look at the examples, we don't see that. We don't see no 3 and 1/10, but we see 31/10. Now, how did they get that example? What they did, they changed the improper fraction. You may ask, what is an improper fractions? Is when the numerator is larger than the denominator. It's called improper, right? Now, what they did, they changed the mixed number. What is a mixed number? It's a whole number connect with a fraction, right? It's a whole number connect with a fraction in the example of 3 and 1/10. So how do we change that back to 31 over 10, well, we multiply the denominator 10 by the 3, which is 30, right? So the denominator 10 by the 3, which is 30. Oh, my apologies. And then we add the answer to the numerator, right? We add the answer. So 10 times 3 is 30, 30, right? 10 times 3, 30, 30 plus 1 is 31. And then we put it back over the same denominator. So 31 over 10. So which is right here, 31 over 10. Boom. So we're going to have half, which is 0.5. We're going to have 1.65, and then 31 over 10, or 3 and 1 over 10. So that would be the same thing, okay? So how do you change improper fractions to mixed numbers? Is by divisions, right? You divide the numerator by the denominator. And how do you change mixed numbers back to improper fractions? You multiply the denominator by the whole number, and you add the product, which is the answer of the multiplication, to the numerator. So in this case, 10 times 3, 30. 30 plus 1 is 31. All right. So quick review. We looked at the number line. We saw that from 0 to 1, it is divided into 10, right? Into tenth. So we got 1/10, 2/10, 3/10, 4/10, right? Right here. And then 5/10, okay? Which is half, right? 5/10 is half. So you can simplify it, right? 5 over 10 simplified by 5, which is the greatest common factor. We'll talk about that soon, right? So we divide both the numerator and the denominator by the greatest common factor, the GCF, greatest common factor. And then we get 1 over 2, or 0.5. Then from 1 to 2, we saw that y was exactly after 1 and 1 and 6 over 10, right? Or 1.6 and 1.7, right? 1.6 and 1.7. So if it is in between, so between 6 and 7, it got to be 65, which is halfway, right? And then we noticed that the Z was way in the back, right after the 3, which is on the first bar, which represent 1/10. So that's 3 and 1 over 10. That's a mixed number. But as an improper fraction, that's 31 over 10. How do we know? We multiply 10 by 3, which is 30, plus 1, which is 31. Okay. And when we compare the numbers, the inequality sign represent an alligator mouth. So the mouth will always eat the next largest number, right? So we started with 1 over 2, then the alligator mouth ate 1.65, and then the alligator mouth ate 31 over 10, or 3 and 1 over 10. All right. Hopefully that explains the problem and that you understand now what would be the answer. The answer in this case would be C, right? The answer would be C right there. Okay. So like, comment, share. All right. Until next time when I post the next problem. All right.